Okay, so today we're going to be doing some things out of section 5.3. We're going to be solving some trig equations. So this is different from verifying identities. Now we are actually going to be solving equations, getting things to one side, and actually getting solutions that make things true. Now, before we get too far into today's notes, I need you guys to get out either your unit circle or your trig table. Trig table may be a little bit easier, but if you have the unit circle, that's basically having the trig table as well. So for the very first question we're going to look at today, we're going to start here pretty basic. I'm going to give you this equation. The cosine of x is equal to 1/2. And I want you to solve this and give me all solutions over the interval 0 to 360 degrees. All right, so this one, in order to get x by itself, the only thing I have to get rid of here is cosine. So in order to get rid of cosines, think back to when you would actually solve for an angle on a triangle. That's really what I'm trying to do here, is I'm trying to find an angle. So another way of saying this is, give me the angle that has a cosine of 1/2. So if we want to think about this in terms of undoing cosine, this is where your inverse cosine comes in. So in order for me to solve for x here, to get rid of cosine, I'm going to take the inverse cosine of both sides, which just leaves x on this side, but then I have over here the inverse cosine of 1/2. Now, what this means is you've got to go to your circle or your trig table and find me all the angles in between 0 and 360 degrees that have a cosine value of 1/2. So if you have your trig table, look down your cosine column, and I want you to write all the degree angles, because we're in between 0 and 360, all the degree angles that have a cosine equal to 1/2. And you're going to see that that happens at 60 degrees. And you're going to see that that also happens at, look for it here, that's going to be 300 degrees. So those are the two angles that make this equation true. And if you go back, you can plug these in like you would in any equation. The cosine of 60 degrees is 1/2. The cosine of 300 degrees is 1/2. So I can see that those are the two answers that make this true. Let's try another one of these basic ones. So for this one, we're going to do the sine of x for number 2. Let's do theta. The sine of theta equals negative radical 3 over 2. This one, let's solve this one over the interval 0 to 2 pi, because you're typically going to do these in radians. Now again, in order for me to get theta by itself on this one, there's really only one thing for me to get rid of, and that's sine. If I can get rid of sine, then theta will be by itself. So to get rid of cosine, I did inverse cosine. To get rid of sine, I'm going to do inverse sine. So theta is going to equal the inverse sine of negative radical 3 over 2. So what that means is theta will be the angle that has a sine value of negative radical 3 over 2. So this is again where your trig table comes in. Now for this one, we want to make sure we're given answers in radians. Scan down your sine column and look for wherever sine is negative radical 3 over 2, and that's going to happen at 4 pi over 3, and that's going to happen at 5 pi over 3. And those are your two answers for that question. Now next we're going to look at what if there are a few other things to undo. So let's try this one. For question number 3, I'm going to say solve 2 sine theta minus 1 equals 0. And we're going to solve that over the interval of 0 to 2 pi. All right, so here to get theta by itself, I've got to move a few things. I've got to move the sine, which I know I can do by doing inverse sine, but I also have to move this and this. Now, if you think about this as just an equation like 2x minus 1 equals 0, you guys know what to do there. You add 1, you divide by 2. Well, we're going to do the same thing here. I'm going to add my 1, which would give me 2 sine of theta equals 1. I'm going to divide by 2. That gives me the sine of theta equals 1/2. So now I'm right back to where I was on the prior 2 questions. To get rid of sine, I do the inverse sine. So theta is going to equal the inverse sine of 1/2. To get my answer there, I go down my sine column and I look for where does sine equal 1/2, and I'm doing this in radians. So theta is going to equal, in radians, pi over 6, and theta is equal to 5 pi over 6. Those are the 2 places on your trig table where sine is equal to 1/2. So those are my only answers in between 0 and 2 pi. Now, some questions will ask you to just solve or find all solutions. Now, if they say find all solutions, just keep in mind that the trig table is periodic. It repeats. And it repeats every revolution around. So if I would ever ask you to find all solutions, you just take the 2 answers you found on your trig table and you would add a complete revolution to that as many times as you need to. So in that case, a complete revolution in radians is 2 pi, so I'm going to add 2 pi, but I can do that more than once. So we throw a k on there to say that k could be once around, twice around, 3 times around, etc. So if this question would have just said solve or find all solutions, you would give me that whole thing as an answer. Again, if the original problem had just been solve over 0 to 2 pi, then you would just give me those. So let's try one more. For the last question for today, we're going to look at, let me change my color back, this one. 3 tangent squared x minus 1 equals 0. And let's do this one just over the interval 0 to 2 pi. All right, so thinking about this algebraically, we're going to add our 1 over, we're going to divide by 3. So I think you guys can follow me to here. Tangent squared is going to equal 1/3. Okay, now from here, the next thing to get rid of would be the square. And I get rid of a square by doing a square root of both sides. That would give me the tangent of x on this side. It would give me the square root of 1/3 over here, but I do have to remember I square root of both sides that that's going to be plus or minus the square root of 1/3. Now, square root of 1/3, that's not a pretty answer, so we're going to fix that. Let's do that over here. That'd be radical 1 over radical 3 times that. So I really am looking for where does tangent equal plus or minus radical 3. So with your trig table in front of you, you're going to scan down your tangent column and find where does tangent equal plus or minus radical 3, and that's going to happen at pi over 6. That's going to happen at 5 pi over 6. That's going to happen at 7 pi over 6, and that's going to happen at 11 pi over 6. And that would be your whole set of answers for that question. Okay, so there you have it. That's what you guys are going to see on tonight's homework.